Okay, this is seventh grade lesson 5.3. The lesson objective is students will find unknown measures and similar figures by setting up proportions. The standard covered is 7G1. The page numbers out of the hardcover book are 206 through 211, and out of the practice journal, pages 115 through 118. Okay, today we're going to be using proportions and setting up proportions to find missing measures. The key thing to remember is that when we have similar triangles, their angles are equal and their sides are proportional. So what they're going to be doing is giving us similar shapes. So here I have similar triangles, and they're going to ask us to solve for an x. So we have to understand and review really quick that when we work with proportions, which we did in our previous lesson, in order for triangles to be similar, remember they had similar cross products. So the key thing on this one is if we were to I like to set up my same shape within the same fraction set or ratio set. So for this first triangle, I like to set it up as 6/8. Now, if you do 8/6, that's okay. Other people like to do common sides, and I'll do that in just a minute to show that you'll get the same answer either way, as long as you're setting it up properly. Okay, then on my larger triangle, this blue one, my 9 is the same as my 6 side. So I need to make sure that I have those on the same level. So since my 6 was on top, I'm going to put 9 on top and my x on the bottom. So when we checked cross products, remember we would always get these to be equal to each other. Okay, well, we can do that cross multiply divide, and it's going to tell us what that missing number is so that we get equal proportional relationship. So here, if I cross multiply, I get 9 times 8, which is 72. And then I'm going to go ahead and divide that by 6. And when I do that, I get 12 for this. Okay, so if I were to check my cross products, I should get 72 for each of these. So that's 72. 12 times 6 still gives me 72. So I know that 12 is the correct answer. So this would be 12 meters. Now, the other way that some people might set it up is they may set up their proportions doing same sides. And this comes in handy later on when we're working with some area situations. So you have to be comfortable using either. I just like to do, when I set up my proportions with similar figures, I like to set them up as the same fraction from the same figure. But another method of setting this up would be to do my blue sides with one figure. And then since this was my smaller triangle, then I have to make sure that I put my 8 on the same level. So then it would be 8/x. You'll notice I still end up multiplying between 8 and 9 and then dividing by the 6. So you have to decide what you are most comfortable with. I will tell you that with shapes, I like to do the same shape in the same fraction because to me, it's just less confusing. Okay, so let's go ahead and try another one. So here we have a triangle. This time we do have some, they're similar triangles. We do have some decimals, and that's okay. I'm going to set this up as this is one of my ratios. So I'm going to do 22.5 over 15. Okay, and if you had those flipped around, that's okay. You just have to make sure that when you go to do your third piece, that you match sides. So my 4 is the same as the 15. So I want to make sure I have those on the same level. So I have the 15 on the bottom. I'm going to put the 4 on the bottom. I'm going to now cross multiply, divide. So 4 times 22.5, it gives me 90. So now I'm going to divide by 15, which gives me 6. So I just found out that this side is 6 meters. Okay. Why don't you go ahead and try this one? Okay, making sure that you're matching sides when you go to set up your proportions. So go ahead, pause your video, work your way through this one, and then check back in just a minute to see that your answer is correct. Okay, you should have gotten 20 inches for the side length for x. Okay, so that's working some basic proportions and figures. Okay, so let's go ahead and try when they give us some other figures where maybe they're asking us a different question. So here it says 2 figures are similar, so we know that both of these parallelograms are similar. It says the ratio of their perimeters is 3 to 4. Find the value of x. So I'm going to go ahead and just set this up as a fraction ratio. Or you could do 3 is equal to 4, and I'll show you on this first one that you could use either method. I tend to go ahead and set this ratio up as a fraction, so 3 over 4. Okay, now the key thing to understand where my x goes versus my 12 goes. I'm going to look at the size of the numbers and compare it to the size of my figures. So since this is the smaller figure, it's going to go with the smaller number. So I need to put my x where the smaller number was, which was on top, and my bigger number goes with the 4, which was the bigger number of the ratio. So now I'm going to go ahead and cross multiply, divide. So 12 times 3 is 36, and divide that by 4, it gives me 9. So I just found out that this is 9 feet. Okay, the other method, and I'll only do this on this one, is you could have done it like this. 3 is equal to 4, which they're not equal, but we're doing a ratio. Okay, then I would match. My smaller one goes in the smaller number ratio, so my x would go here, and my 12 would go here. Take note, I'm still doing 3 times 12, okay, and then dividing by 4. So once again, matching, you decide what you're comfortable with. I like to go ahead and just do my ratio and then match from there, but you have to decide what you're more comfortable with. So let's try another one of those. Okay, 2 figures are similar, so they're telling us they're similar. The ratio of their perimeter is 7 to 10, so I like to do that as a fraction. So obviously this is my small figure, this is my larger figure. So my smaller figure was an x, my larger figure was a 12. Cross multiply, divide. So 7 times 12 gives me 84. Now if I divide that by 10, it gives me 8.4. And they didn't give us units, so we'll just leave it as 8.4. Okay, so I'm going to give you guys one to try. Okay, go ahead and try this one. So pause your video and then work your way through this one and then start it back up to check your answer. Okay, you should have gotten 6.25 inches for the missing side of the smaller figure. Key thing on this one is making sure that you're matching those sizes. So when they give you the ratio, the bigger number goes with the bigger sized figure. Okay, so that's just working some basic proportions. Now we're going to go ahead and work with what they call indirect measure. Now, indirect measure is where you're going to use 2 figures and you're going to use the measurements to be able to figure out the height or a missing figure on the other one. So take note that as I set these up, really we're creating a right triangle on these. And you guys just got done with working with similar figures. So here what they're doing is they're using the sun and they're measuring the shadow. Okay, we could measure this person's height. We found out that this person was 6 feet tall and we know that their shadow, so I do the actual object over shadow. Now you don't have to set it up that way. Okay, you can also set it up, where you do your heights in one ratio and your shadows in the other. I just tend to do the same figure in the same ratio. So there's my 3. Okay, on the bigger figure, I don't know the height, but I know that the shadow, which was my bottom number, was 15. So we're going to cross multiply and divide. So here we are using the sun to measure the shadow, and since it's taken during the same time of day, that ratio is going to be proportional to each other. So 6 times 15, and then we'll divide that by 3. It gives me 30. So this would have been 30 feet for the height of that tree. Okay, so looking at them as if they were similar figures and understanding that indirect measure is creating that triangle of similar figures. Okay, so let's try another one. So this time I have the Statue of Liberty and a person that's 6 feet tall. Okay, I like to set this up as one proportion. So the actual person over their shadow. On the Statue of Liberty, I don't know the actual height, but I know the shadow was 75 feet. Cross multiply, divide. So I just found out that the height of that Statue of Liberty was 150 feet. Okay. Oops. Okay, so I want you guys to go ahead and try this one. So go ahead, pause your video, try working through this one, and then we're going to do one additional one together. Okay, here we found out that the person was 6 feet tall. Now, to be honest with you, you probably will never use indirect measure to find the height of a person because it would be easier to measure their height than it would be to measure the height of the tree. But it was just giving us another sample of where we can find that missing measure when working with indirect measure. Okay, so this next one is a little more complex because it's a word problem. So here it says the shadow cast by a 1 foot ruler is 8 inches long. So I have a 1 foot ruler. So here's my ruler. Okay, and it's 1 foot here. And the shadow that it casts is 8 inches. Okay. Then it says the shadow cast by a pine tree is 24 feet long. So here's my pine tree. And the shadow that it cast was 24 feet long. They want to know the height of this. Okay, so here's the thing. Here I'm working with some inches, and here it's in, whoops, and I forgot my 4 there. Here it's in feet. So I need to convert so that they're all in the same measure. So what I'm gonna, or unit. So what I'm gonna do is I'm gonna divide this by 12 because that's gonna change that into feet. So if I do 8 divided by 12, it's gonna give me 0.6 repeating. Okay, now I have to remember that when I go to set this up and put this in on my calculator, that I need to do that as a repeating 6. So as many 6s as I can put in there as possible. So I've got 1 foot over 0.6 feet is equal to, well, my 0.6 feet is the same as the 24. So I've got 24 there. Okay, so we're going to cross multiply, divide. So 24 times 1 is 24. Divide that by 0.6 as many times as I can put it in there. And that's going to give me about 36. Some calculators might give you a number that's close to 36, and some calculators will actually take that 0.6 that you put in there as 2/3. So here I just found out that this is 36 feet tall. Okay. Key thing there, make sure that you're not just using 0.6 there. It's not very often. This is a more advanced question. Not very often that they're going to give you those, but sometimes they do. Okay, so let's try one more of these where it's a story problem. So I like pictures. Some of you can do it without pictures. So it says a building casts a shadow of 420 meters long. So here's my building. Okay, and the shadow is 420 meters long. At the same time, a person who is 2 meters, so here's my person, they're 2 meters tall, casts a shadow of 24 meters. They want us to find out how tall this building is. Okay, so I've got my 2 meters over 24 meters. And then over here, the shadow was 420. I don't know the height. So now we're going to cross multiply, divide. So 2 times 420 gives me 840. Divide that by 24. Ends up giving me 35 feet. For the height, or not feet, sorry, meters. I labeled it as feet. So 35 meters. Okay, so the key thing on working with the stuff out of this lesson is setting up the proportions. Make sure that you're matching like units. I like to, if possible, if I have them in the same shape or in the same indirect measure format, I like to put them in the same proportion. But then the key thing is making sure that you are same ratio. Key thing is making sure that you're matching the side lengths that are the same or those similar corresponding sides. Good luck with this one.